Welcome to Startuprad.io, your podcast and YouTube blog covering the German startup scene with news, interviews, and live events.
Welcome everybody, this is Joe from Startuprad.io, your startup podcast and YouTube blog from Germany. I'm right now here in my cramped study again, and I'm talking to Johannes, who's the co-founder of a VR startup from the lovely city of Mainz, where I was born, and I'd like to welcome him.
Yeah, thanks for having me. Hey, glad to have the opportunity to introduce Flying Shapes to your audience. Great.
Totally my pleasure. At first, we should start saying you guys are actually a B2B startup, so you help other companies with VR. But before we get into your actual product, can you tell us a little bit about what you did before? And disclaimer, I stalked you on LinkedIn, so I've seen a lot.
Sure. So you learned that I'm actually a physicist. So I studied physics, and I even did my PhD in particle physics at CERN. And then I had the choice to stay in science, or, well, in my case, I wanted to. My other option was to start a company. And so since I decided that science is not predictable enough, I decided to start a startup instead. So after my PhD, I had to decide whether I wanted to start a company now or stay in science. And so the time was right for me to do this, to take this step. And I browsed through a number of ideas that I had back then and looked for co-founders. And actually, it was here in Mainz at the so-called Gründertreffen, so the founder meetup, where I met my co-founder Johannes. We knew each other from the university, but we didn't know about each other that each of us wanted to start a company. And it was actually on that particular date that we decided, okay, we need to start something together. We just need to figure out what it's going to be. And then we browsed through a number of technologies and ideas. And it was 2016, so VR for the mainstream users was pretty new back then, and we tried out, I think, the Oculus first, and then the HTC Vive, and we immediately fell in love with the technology, and we saw a huge potential and thought, okay, this is going to be the future, and we need to do something for this. And then it took us quite a while of brainstorming, of trying out ideas. We went to meetups, to a hackathon, and until we came up, or in subsequent steps, with the idea to build a CAD application for product designers, transportation designers, architects, because VR has the huge benefit that you immediately have a 3D impression of what you create or what surrounds you. So this is what triggered us from the first time, and yeah, really gave us this momentum to get this started, this project first, and then the company.
I see. Since our audience is more than 90% not from Germany and 2/3 not from Europe, we might want to give them some background, especially if they are not in design. So just a tiny bit more information on CERN.
Oh, sure. CERN, well, for those who've seen, sorry, I don't get, I can't. Right. For those who've seen The Big Bang Theory, they may know about CERN. It's actually a particle science laboratory. It's one of the great international laboratories in Europe, besides the European Space Agency. And there's particle physics research going on. They discovered the Higgs boson in 2012. So it's one of the coolest places to be in high energy in particle physics. This is where the frontier of research is redefined right now and has been over the last years.
Very fancy place. Before we get to the point where this actually connects to what you guys are doing now, we just may want to add that CAD is computer assisted design, right?
Computer aided design, exactly. So it's about constructing, in our case, designing 3D or 2D objects on a computer. So before you did that with technical drawing, very fancy. It took quite some time to get into this, and actually my mother taught that at school, by the way, with the classic version and then CAD. But yeah, it's about like constructing and designing products that reach from, I don't know, can be layout plans for computer chips, but up to like nuclear power plants in all details. But of course, also the design. So you would also model the exterior design of a car, for example, in a CAD application.
I see. And we actually met in person last time at Entrepreneur University, and I was taken aback a little bit. Physicist, PhD at CERN, and then he's doing computer aided design. And the question was for me instantly, how does this connect? And actually said that it has a pretty big connection because in the part of physics you're working with, you have a lot of abstract data and want to make it visible, understandable, right? That's kind of the connection.
For me, there are a few links, and also for Jonas, that have also to do with the fact that it's going to be, or that it's a VR application. But I came up with another link only recently, because for my diploma thesis, so before I did my PhD, I actually worked on, it's a bit too detailed probably, but on track reconstruction. So trying to figure out which tracks charged particles took through the detector. And to do this, you need to know the geometry of the detector. So you need to think of something that's as big as, well, a bigger office building, but it's like packed with technology. And you need to know exactly where, like on the sub-millimeter level, where exactly which part of the detector is located. And I didn't work with CAD data, but I worked with something that was derived from CAD data. So that was also like a connection point that I came up with only recently. Besides that, the processing of especially the real-time processing of huge data sets is something that we did at CERN, which is very crucial for VR, because you always have to keep the frame rate at a certain level. And so the real-time aspect, so I need to define when whatever I do in terms of processing, in terms of data processing, when that's done, this is absolutely crucial. And this is something that we can take from our CERN experience, because there also real-time data processing with high-speed computing is one of the things that we did there. Plus CAD, of course. CAD itself has a lot of maths. You need a lot of math to understand the underlying principles, and this is something like differential geometry that you also in parts learn in your physics studies. And then we also knew, again, that was my diploma thesis. My supervisor is a computational geometry professor here in Mainz. And so also there we learned about Bezier curves and all that kind of maths and algorithms that you need for CAD. So there are a few joints where the step was, or that make the step kind of logical for us, at least like looking back at it. And so that's like these 3 or 4 points are clearly a connection from our CERN work or from our work at the university to our startup that we now do.
I had to smile a little bit. A professor in computational what?
Geometry.
Can you explain a little bit what that means? Because I got a business background and I got no clue what this is.
Well, I hope I picked the right word there in English, but well, I mean, it's about it's computer graphics and computational geometry, and so I don't know if I can really fully explain that. I'm sorry for all the computational geometry people out there, but from my understanding, it's, for example, if you want to in our case, Tesla, it's a bit complex to from my perspective to even explain it. So we have like rounded curves, for example, and they are defined as very simple equations mathematically. So you could write that down in like a line of equation. That's simple, at least if you're used to like theoretical physics. But the the computer needs to sorry, the computer needs to, I mean, when you draw this on the screen, it's not going to be this equation anymore, obviously, because it needs to be rendered to pixels. Because everything that's displayed on a screen, for example, or also in a VR headset, is in the end like just a set of pixels. And this transition from the mathematical formula to the pixels is something that depending on what you do is called rendering or tessellation. And doing this efficiently, for example, is one of the things that one might look at. Or there are other use cases where you combine computation and geometry. What I know my professor worked on is packing circles or packing disks. If you imagine you had like a bunch of actual disks and wanted to pack them as in a circle that's as small as possible, or maybe better for your audience to understand. That was also a use case. Let's say you want to find out how big. Sorry, I need to rephrase that. So there's from my understanding, there's a kind of regulation that says the trunk size of a car is defined as the number of defined volumes that you can put in there. Imagine like you had to make a stack of like milk boxes, and the number of milk boxes tells you, okay, this trunks, there are like 100 milk boxes that fit into this trunk, and this is how we define the size of the car trunk. And that obviously makes it necessary to like kind of optimize how you position these milk boxes in the trunk, because you want to have that number as high as possible, because you want to say, okay, our trunk is like that big, and people tend to probably want bigger trunks. So you say, okay, the better I can fit these milk boxes into my trunk, the better it is. And that's a kind of optimization. And how you do that from a computational aspect, that's also something that professor worked on. So from my understanding, these are like cases where maybe I'm not fully right there, that this is like still computational geometry, but it's at least related. So yeah, that kind of, let's say, algorithms that have something to do with geometry, like geometrical objects, and where you, for example, want to optimize things, make them faster, make them optimal. I think, yeah, maybe that gives an idea.
Totally fine. Let's get a little bit to flying shapes. People who are watching this YouTube video will now see a little bit of video footage from designing of a car in your software. And can you tell us a little bit about what are you guys doing? What's different about it, and how you approach all the problems with your startup?
That's a huge question, actually, a set of questions. So
here at Startuprad.io, we don't do the small questions.
I try to like work through them. So what Flying Shapes does? Well, maybe I should start like introducing the product itself, because I only teased that. The software that we build and now sell, Flying Shapes, is an entire CAD application. So it's a standalone software that you can just download and run if you have a sufficiently powerful PC or laptop and a mainstream VR headset. And we are one of the first providers of such a tool that allow you to design entirely in VR. So you could start with the first sketch, like really sketching in 3D. That's something that you saw in the video, and from there on you can go to the next step and refine your sketches with like I mentioned, these parametric curves that can be, in our case it's B-splines technically, but let's just think of them as like very smooth curves that can be used up to the production stage. That's from an industry perspective. And from these curves on, you create the surfaces that define for example, the exterior of your car, or the surface of your seat that you might model, or the exterior of your coffee machine, or your piece of jewelry, your chair. There are many use cases where we see our application being used, and where people can benefit from that like direct spatial impression that you have. So and like I said, this is a standalone software, so you can download it, get started right away. You can, of course, import things. So if let's say you have, that's a common use case in the automotive industry, you have a called package. That's, for example, a set of wheels. You can import that in any CAD format, and then start modeling around it. So you have your wheel position defined and can start constructing your exterior design around that. And from there, like I said, you can create the curves, you can create the surfaces, you can refine them, you can review them. So that saves you a lot of model building, because classically, at some point, at least in this process, people would start building physical models. At some point, there will be clay models that are made from an industrial kind of clay. They are first, I think, 1:4 size, then they go up to 1:1 size. So you can imagine that there's creating a 1:1 sized clay model of a car is, of course, quite costly, quite time consuming. So all these steps are very costly and take a lot of time, and you can save a lot of them. That's at least where we see a huge potential in the software. If the designer can work in 3D all the time and not only see his model in 3D when they finally build this physical model from it. And then at some point we say, okay, when the design is finished, in the current version, we're not yet there, but this is where we want to get. When the design is done, you can export it and, of course, refine it again if you need, but at the end, you'll either be able to give it to 3D printing or production, or give it to people with more technical CAD tools that do some technical refinements if there are requirements that need to be still enforced. So this is where we position the software. This is where we see the biggest benefit. And actually, that's like that. Being able to see everything in space, like in 3D, we think that makes a lot of difference, because I've just recently seen a video from a designer. I don't know which. It was one of the big manufacturers, the German ones, and he said, special moment when you first see, like, you've been working on the design, refining it for weeks, and then there's this magical moment when you first see the clay model that's produced from this. And this told me that there is a lot to benefit from something like Flying Shapes, because of course I fully understand why he said that, because it really is an entirely different feeling that you get for the design when you really see it in 3D in front of you. But this is something that we can offer from the from the starting point. And this is only one of the benefits, because if you work in Flying Shapes, we don't have this in the release yet, but we have it like here. You can collaborate in real time with people from different places. So it's not only the design review, but even the modeling that can be done from remote locations soon. And people will see each other as if they were working in the same room, just in virtual reality. And this is also something where we say, okay, these OEMs from, for example, the car industry can benefit a lot from such a tool. Because people can collaborate. If you say, okay, I need some expertise for this particular design feature, but the colleague is located in, I don't know, Los Angeles. Well, I need to keep the time difference in mind, but besides that, it's no problem. He can just join and do the adjustments or review and make some changes immediately, and that's it. So it's going to open a whole new chapter of, for example, automotive design.
That pretty much sounds like it is a VR design tool plus a VR cooperation tool.
Yes, I would say so. So design is, we have used the word CAD, but it's not only CAD, it's also that sketching aspect. And reviewing. We have actually dedicated tools for design review activities. So there's it's more than CAD. It's the CAD capabilities are a little limited now, but on the other hand, we have a wider range of steps that we can cover, or where users can benefit from the software already now. I mean, it's only been released very recently in the first version, but we are still working on features that are added on more hardware that we will support. And like I said, the collaboration is already there in the testing version, but it's not yet ready for release. So we'll release that next year at some point. There's a lot to come still, but that's what I would say we cover: designing, collaboration, reviewing, sketching, so concept modeling. This is where I would position our software.
So it's a little bit more holistic approach, which actually would help to accelerate the development of new products, right?
Yeah, that's what we absolutely see in this. So, I said, there's the benefit that we see from the automotive users, but also if you think of an industrial designer, there we say, okay, very soon you should be able to cover the entire process in that software. So from the start until you can send the final design to your customer, to your client, and also in the intermediate step, do the review. So you can send your client, or if he has a VR headset at his in his office, it's possible for him to just log in. You can also then join with a mobile device or from a desktop PC, but the full experience is only available in VR. But this is, like I said, also for a client possible to join and review what the design team is working on. And so I think it's going to be the perfect solution for a small design studio and a huge benefit for a bigger company. for maybe I should add that to the car manufacturer use case. Today, they have a very split up process. So there's the designer who works in 2D. In many cases, they work maybe on an iPad or in Photoshop, or classically on paper. There's the CAD designer who takes the designs, the renderings, as it's called, from the designer and transforms them to 3D. So to CAD model. In some cases, this can be a polygon model, but which is easier to build but harder to change, let's say. And then this is going to be like modeled in clay. And these are three different roles, at least. Maybe there can be one more for the final CAD model that's going to be more like precise and has to fulfill certain requirements. So there are 3 to 4 roles in that process that are involved that have interfaces. And that's also something where we see that, or we claim that in Flying Shapes, these people can be like brought closer together, and their areas of expertise will overlap, so they can collaborate inside the same tool, don't need to switch from one tool to the other, and they can work more closely together, such that the losses of information from each step or at each interface will be way less, or at least or maybe even completely gone, because people can work together at the same time in that common environment.
I understand that. Before we go and talk a little bit more about the startup itself, just who is still listening out there? Which type of people should have a look at your software? What type of people is your client base? Which one would you address like personally right now?
I think that for any product or industrial designer who works on like objects that are in 3D, so in most cases that's the case for, or in many cases that's the case for a product designer, it makes sense to look at Flying Shapes. Because even I think, and that's also like a view that we share with other people from the same like industry, that there's going to be a transition to VR. It may not be the tools that are there today, but we will see a fundamental change in the tools that are used. So if you work in product design, industrial design, transportation design, or maybe also interior design, and maybe also architecture, it may make sense to take a look at Flying Shapes, because you can benefit a lot from the improved process with respect to classic CAD. You get rid of all that abstraction that you have between the 2D surface on the screen and the 3D model that you build. And we would say that this is such a great improvement that at some point in the future, a lot of design work will be done in VR, because it's such a huge benefit. So if you I think if you're a young designer just starting, I think it makes a lot of sense to look into this, because then you can be ahead of like your colleagues, because this field is just starting, and everybody has to figure out how it's used, or how you can benefit best from the new possibilities. But I think it's the right time to get started for anybody like who's curious, who's maybe just starting, but also for people who have a lot of experience and are frustrated with the old limitations. That's something actually we have a lot of like real fans of our software. They can be like I don't know, in their 50s, and they say, okay, I've been working on like surface modeling, as it's called, for ages now. I know all the professional tools, but it's always such a limitation actually that I felt, and I've been looking for something like your tool for so long now, and finally it's getting there. So this is that feedback is something that tells us, okay, we've found something that's really interesting for many people. These sectors, of course. By the way, we have a freemium model. So if you're just curious, want to get started in doing CAD and have maybe a 3D printer and a VR headset, and I know that there are like tech fans that have both. Personally, I'd be exactly that person if I was not working here. Then yeah, this is why I'm building this also for myself. Then you might also try this out, because I know my sister, for example, and her husband, they have a 3D printer, and they can do CAD, but it's always hard to get started. And with Flying Shapes, it's way easier. And so if that's your use case, try it out. You can use it for free, and it's pretty cool.
Okay, we'll definitely have a look there. Just talk a tiny bit more about Flying Shapes, the company, and your team. How many people do you guys actually have right now?
Right now we're 11. So I would like to have like double that number, but we're working on that. So yeah. The company, well, we founded Flying Shapes in 2018 in May. We started the project, like I said, in 2016. So there was quite some time that Johannes and I worked on it on our own, doing the development behind the scenes. The first time we showed it to the public was already in 2017 at CeBIT, which is a huge like computer fair here in Germany. We won a booth there in the startup area in a competition, and that was a cool story actually, because we learned only like 2 weeks before the CeBIT started that we would have that booth. And back then we had a prototype that kind of worked, but there was nothing else. So there was no company name, there was no design, there was no website, no business cards. And all of that needed to be like completed within 2 weeks. And that was quite intense, but it was a huge success. So there were actually people it was a very early prototype. We had been working 3 months on that. And there were people from, I think, Audi, or at least from huge car manufacturers, that were standing at our booth and said, "Wow, this is cool. This is impressive. We want to learn where this is going. Keep us up to date about where you are." And that was an amazing like start actually back then. That just as an anecdote. And
one more question: how you guys are actually financed?
We started with our own money, but that we ran out of that soon. Especially when it comes to hiring people, of course, you need funding, and so this is why we went the standard startup way. We pitched at different pitching events, and we're looking for investors. On the one hand, business angels. On the other hand, VCs or other investors. And so we've completed 2 financing rounds now, a pre-seed and a seed round. Pre-seed was last year. Seed is, we've only just recently released the announcement that it's called ISB, Innovations- und Strukturbank Rheinland-Pfalz. So it's a state-funded VC that has invested, plus the last round, and they also joined in this round, is a local Mittelstand company, so mid-sized corporation. Bito Campus is their investment arm, and it's like a corporate VC. They invest into startups that they find interesting from a strategic perspective. And they're located here in Rhineland-Palatinate, and they did the first round, and like I said, they joined also in the second. And we'll go on with subsequent investments, because it makes a lot of sense for us to scale the business to a larger scale, because this is what makes most sense for us. We don't want to only build a tool that's cool for designers. We want to at some point build a VR CAD platform. So this is where we are going, and it's a bit like I don't know if your audience knows Onshape. Maybe they have been called a unicorn. I don't know about their current status actually. They might have been bought, but I'm not sure. So Onshape is one of our idols in that sense, because they have taken CAD and transformed it to mobile. So you can use CAD in the browser or on an iPad, for example, with their solution. And they've also built a whole ecosystem, so you can get a whole lot of plugins for that. And it's a huge ecosystem that has established around that tool, and this is what we want to build for VRCAD. On the other hand, you could compare it to something, maybe your audience also knows Unity. They're also in some sense still a startup. It's a very common game engine, but it's also very common in VR. So actually also our software uses it. And I think they've just done another funding round, and they've got a multi-billion valuation. And they have a freemium model on the one hand, and on the other hand, they have a huge ecosystem of other companies that sell their add-ons to the engine on their Unity asset store. And like these two models are a bit like our landmarks for where we want to get at some point. So next year we plan to do a Series A funding round, and for this, of course, we're not actively looking for anything right now because we just finished our seed round, and we're quite busy working on building up the sales force for our team, get to the revenues that we want to achieve this year. And for next year, we look for investors that are interested in a deep tech software as a service startup such as flyingshapes, and who believe in VR as a technology. And I think we're talking about sometime mid next year when we're probably going to raise the next round. And anybody who feels like this could be interesting for him, maybe because she is interested in the car sector or design in general, or deep tech, VR collaboration solutions, everybody who can relate to any of these subjects is very welcome to reach out to us. There's going to be a next round. We have a huge potential that we see in the development of this company, and we're very happy to tell you more about our vision anytime you reach out.
And everybody who'd like to reach out and learn more, go down here in the show notes. There is a link to our website, and on our blog post on the website, there is the link to reach you directly, your LinkedIn profile, as well as the company website.
Great, thank you. Yeah, I'm very happy to connect, and it would be great. So I would be very happy if we find more people. Our existing investors deeply believe in our vision, I think, and I think there are going to be more people who see this potential of a breakthrough solution in the CAD and design industry on the one hand, but also in the VR tech sphere and the collaboration, and who join in on that VR CAD platform vision.
Great. It was one of the interviews that I had to say the least, which is great because the audience already knows me and knows my voice. So thank you very much. It was a pleasure having you, and will be definitely one of the longest interviews we had this year. Thank you very much.
Thanks for having me. It was great talking to you. And yeah, thanks for having me.
Bye-bye. Bye-bye.
That's all, folks. Find more news, streams, events, and interviews at www.Startuprad.io. Remember, sharing is caring.